back to the 5G Summit on Federal News Radio. I am your host, Jared Serbu. Thanks for being with us. Also with us are Dan Elmore, the Executive Director at the Wireless Security Institute at the Energy Department's Idaho National Laboratory, Tao Zhang, Manager for the Emerging Network Technologies Group at the National Institute of Standards and Technology. Jody Little is with us from the Air Force. He's the Executive Program Manager of the 5G Next Gen program at Joint Base San Antonio. And Bob Zapataki, Senior Principal Architect for AT&T's Global Public Sector Business. And Bob, let's start with you in this segment. We didn't get to you in the last segment, but I'd like you to weigh in a little bit on some of the standards issues that Jody started to touch on in the last segment. COVID-19 has changed everything, including, I'm sure, a lot of things about your business and implementation of 5G. To what extent has the pandemic inhibited what is, I know, an ongoing process in developing those standards that AT&T has got to adhere to or going to adhere to?
Mm-hmm. Yeah, thanks. So that's very, very true. What we're seeing, the standards body, 3GPP, has really, driven 5G standards, actually mobile standards, for quite some time. And Release 16 was just released recently. And what we found is as COVID-19 became a problem, as the pandemic expanded, a lot of the activity that typically moves those standards forward with technical specification meetings and so forth was delayed. They had to move into a virtual environment, as everybody else did. And so the standards release, or the release of standards, has actually been delayed over time. Those standards actually define what manufacturers will, and chipset manufacturers and OEM manufacturers for equipment will deliver, will actually do the research and deliver to the field. So typically, if a standard is released, it's an accepted standard and will become widely used. It will take 12 to 18 months for an OEM then to manufacture and deliver services or deliver product to a provider who will then test that before deployment in their network. So as that delay is like a domino effect. A delay in the release of the standards delays the equipment from being manufactured, which delays the implementation within networks. And that can become a problem. Now, there are, organizations may take a risk and try to go before standards, but that typically doesn't happen. And many of the standards, I think this was pointed out earlier, many of the standards that are actually created may not be implemented or may be very narrowly implemented, depending upon what the requirement is from a use case perspective. So those are important factors when it comes to deployment of the equipment in the field and deployment of the services that Jody was speaking about.
In terms of people moving forward with draft standards that are not finalized, why is that so rare? Because my guess would be, as an outsider who doesn't know a whole lot about this, would be there are at least some cases where we're pretty darn sure this is the direction the standards body is going. So it's relatively safe to start manufacturing devices and chipsets. It just doesn't happen very often, you're saying?
Well, if you think of kind of the impact of being wrong, it's pretty significant. So the research, the testing that's done, the deployment that's done costs a significant amount of money, billions of dollars. I believe that R&D budgets on let's just say a worldwide basis for mobile technology is somewhere around $500 billion on an annual basis. So if you happen to move in the wrong direction as an OEM, or even as a network provider, it can be extremely costly. So, again, this is probably one of the reasons why development of the standards is critical in order to be able to deploy the services.
Dan, let me come to you next. Let me start with actually the same question that I just kind of asked Bob. How much of an impact have you seen from COVID in terms of your ability to get out there and experiment both on the range and in the lab? And then I think you also wanted to weigh in on the standards piece too.
Yeah, sure. I'll be honest. We've been very fortunate, right? The way we were allowed to operate, mostly telework, right? Probably 50-60% of the lab teleworking, but allowing customers to come out to visit, to do work on the range throughout last year. we were worried about a year ago when this all kicked off what the impact would be. But we're able to keep people separated, smaller groups, smaller research teams, et cetera. But the pace continued. I mean, we successfully installed 2 5G systems in our laboratories through the end of last year, and actively working for our first tier 1 non-standalone 5G out on the range, which will be operational this summer. So really hasn't impacted us as much as we had thought it might.
That's great news. What's your perspective on the whole standards discussion that we were just starting to have?
Yes, sure. Our focus here clearly is the security piece of all of this, and that's one of the large gaps as we look and surveyed the research world, at least in the United States, of who's working on what, and the security is a gap area, and that's where national labs play. Really, is looking at problem sets that industry or academia may not be focused on for various reasons. But as the standards roll out, yes, 5G has a much richer suite of security features than 4G in the previous versions. But many of those they're not mandatory, right? So for mission critical applications and uses like that, maybe military and others, some independent validation of how did the manufacturer, right? They said they did, but did they really? And what does that look like from maybe an adversary or vulnerability aspect?
Tal, let me come to you on that security piece a little bit to expand on sort of the underlying architecture of how 5G works. As some of our panelists have already said, there are some inherently more secure features in those standards, as Dan says, if you actually implement them. But as we start to think about a nationwide 5G rollout, what are to you some of the unanswered questions about how to make 5G as secure as possible?
So 5G, as we know, adopted roughly the same security architecture as 4G. It provided a range of additional features, things like, for example, to enhance user privacy protection by transmitting permanent user identities now in ciphertext encrypted. And before that was not always the case. And interface security was enhanced by adding things like more integrity protections, and roaming security was enhanced. Some features were added to support the new capabilities of 5G, for example, network slicing. But largely, if you look at what the focus of the 5G security is, it's still focused on securing the basic connectivity, meaning that authenticating the users using the system, securing the confidentiality and the integrity of the connectivities, but extending those connectivities not only just between the networks and the mobile users, but between network providers and so on. So 5G actually opens also a range of newer security challenges that have not been very adequately addressed. So many of those, if you look at 5G, for example, the trust relationships becomes much more complex. In 4G and before, trust relationship provided by the network is mainly between the user and the network who provides that service, the home network and the visited network and so on. So now 5G has this emphasis of providing newer services, and the entire trust relationships needs to be sort of a much more comprehensive, to include trust relationships between not just the users and the networks, but between the users and networks and the services they provide, and the virtual networks and the physical networks. 5G also sort of introduces new technologies. Those new technologies come with newer architectures and architecture elements. For example, network software-defined networks and network function virtualization. So you're increasingly implementing a network in software, and there is a software layer now, virtualized software layer now, that was not before there. So that introduces more attack surfaces and more sort of interesting and harder to deal with security issue in 5G has to do with securing the network slices. So those network slices, as you know, are virtual networks. They share the same physical infrastructure very often. And they're implemented in, for example, containers or other virtualization technologies, but they run on the same physical network. And how do you protect, for example, different network slices? How do you isolate the compromises to one slice and isolate the impact to other slices, so that, for example, when some network slices were compromised, the compromise won't spill over too much to the other slices to impact, for example, mission critical slices. And the service models are also more complex and so on. So given, and also the critical nature of 5G and the fact that many of the 5G systems may actually be more integrated with user systems. For example, 5G LAN is going to become part of a manufacturing, for example, facility or in a local facility, just like, for example, our regular Wi-Fi LANs maybe. And so all of those says that you really need to go beyond just providing, just securing and connectivity. You really want to introduce, for example, threat handling capabilities in a much more comprehensive and a much more network native manner. So those are newer capabilities that are typically done now over the network by different ways. 5G does provide a range of data collection and data analytics functionalities that can support those higher level and more comprehensive security capabilities, but that area I think is worth looking into a lot more.
Are there lines you can draw between where it's the responsibility or it's even rational for the security piece of things to be baked into 5G standards compared to the 5G folks saying, hey, I'm just delivering connectivity. It's up to you to secure your edge devices. How are we currently thinking about where to draw those boundaries? What's up to the network and what's up to the end user on the network or the architect of whoever's putting stuff on the network?
That's precisely one of the key issues that has been discussed, and not sure all of those would be addressed in 5G. A lot of the so that's why sort of people are actually aggressively thinking about 6G. Research have started 2-3 years ago widely already, because the 5G framework is there already. It does have its limitations, and so the answer to the question you give is complex because of the fact that a part of the 5G, especially some of the edge part of the 5G, is going to get more integrated with consumer systems, with user systems. Unlike before, you have a sort of a closed up SIM card that you give to your users, and that's the end of it, right? And users don't know what's going on inside. You have control over everything, you secure it, and so on. So now your systems, like the 5G LAN, for example, will be much more integrated with the user system. So it's getting more difficult to decide which part of the security protections should be provided by the network provider, which part should be handled by the user. For example, how much visibility should the user have into the 5G LAN security configuration traffic, so that to monitor and to detect threats and so on, and how much of the threat detection and threat handling and threat mitigation capabilities should and can be provided by the network provider, especially at the service level, the network slices and the service level. Going forward, and 5G already allowed some of the the network slices to be exposed to users and to even be controlled by users to some extent. So that actually make the security question even more complex.
Jody, you're nodding a lot again. Let's go to you next on how DoD is thinking about some of this.
I'm agreeing with Tao. We're concerned about different levels of the security. First off, as we talk about 5G security in itself, what we're going to see is applications riding on top of this that'll be tailored, running on different cores out through the networks. And so how do we ensure that the applications that they're building running in the 5G don't introduce threats? We also go to the other end of it. How can I protect the secure slices? And as Tao said, so they don't creep over into other slices and they remain consistent. And the big question is, how do I monitor that? So that they haven't been compromised, the best ability. So from a DoD standpoint, we have to be concerned all the way through. And on top of that, it's got to be a repeatable process in the future on how can we secure applications and accredit those, that they are staying within the standards, within the additional standards that DoD is going to have on top of it, and are secure. So that we have a fairly complex situation. I want to comment on Tao's 6G thing. I agree with what you said on 6G, but it concerns me that we're still as a nation struggling to get 5G right. And when you bring 6G into play, you add even more to it, complexity to it, to get there. And I think we have to go through the 5G to get to 6G to make ourselves a viable use of the technologies. I also get concerned that the nation, the developers core, if you will, the industry base to do 5G developments hasn't achieved any synergy. And there's a lot of training that has to be done. And that training needs to include cybersecurity associated with 5G in it. And I've seen that most of the universities we've been talking to are teaching some 5G, but on the security side, it's usually something embedded, like one module embedded in a course, as opposed to heavily focused. I think you're going to see a lot coming out of INL under Dan's organization, where the things they're learning and doing are going to have a major impact on the 5G community as they continue down their line. And that's important to our side on DoD as well. Getting 5G secured. They push the concept of zero trust. It's this decade's buzzword, but it is a true capability that's needed. How do we guarantee zero trust through those networks? And that's where we're focused at JBSA.
Need to take another break here. We'll be back with all of our panelists on our 5G Summit. Thanks for watching Federal News Network. I'm your moderator, Jared Serbu. Back in just a minute.